Yeah, absolutely.
Hello, everyone. Welcome to tonight's data science meetup, the Actuaries Institute. Actuaries and data scientists are collaborating more than ever on initiatives like enhancing service models and supporting digital transformations. Our meetups are general opportunities for actuaries and data scientists to explore issues that span our allied skill set. I'd also like to highlight the Institute's Data Science and AI Scholarship with Chief Executive Women. This scholarship offers up to $25K for leadership courses at INSEAD, Stanford, or SIDE business schools. If you're eligible or if you know anyone interested, please scan the QR on the screen at the side of the room. You can also visit the Institute's website and have a great session. And I'll hand over to Eugene.
Thank you very much, Aidan, for that great introduction. And thank you all for coming. Got almost a full house. Almost always a good sign, and not terribly surprising, given the topic and the currency of the topic these days. Hence, as you know, the former Data Science Sydney is now Sydney AI and Data Science. And well, without much ado, let me introduce our speaker. So we only have one speaker today because the topic is that interesting that it warrants pretty much all of our attention. So David Triggs graduated with degrees in electrical engineering, computer science, followed by a long career in Australia and then across the Asia Pacific consulting on data center software, especially focused on performance and doing things like getting 21 million clients on an Oracle database in real time. An interest in the limitations of symbolic AI led to a master's in cognitive science, the interdisciplinary study of mind and intelligence, embracing philosophy, psychology, artificial intelligence, neuroscience, linguistics, and anthropology. However, until recently, there seemed to be more immediate opportunity in consulting on data science in domains ranging from customer interaction, financial services, through failure prediction in industrial equipment, to analytic platforms for agriculture, including aerial imagery, leading in turn to an interest in deep learning and getting AI to work well in human processes. So that's a brief but very impressive introduction to our speaker, David.
Thank you, Eugene. So we've had a couple of sessions on AI and lots of different opinions. And one of the things that I thought would be helpful was to try and look at these tensions we're experiencing on the one hand, where people are excited for the benefits of AI, and on the other hand, concerned, are we ready? Do we know how to use the technology to manage it properly? And I want to do that by looking into specifically some of the things that have been built the last few years and a bit about how they work, not to make it a technical discussion, but just to go in far enough to understand the implications. And so Eugene has done a wonderful job of presenting my first slide. So let's dive straight into AI, which, as everyone knows, stands for Apple Intelligence and was invented by Apple last week or the week before. Just kidding. So one of the things that I think is quite interesting about AI is that whenever people start talking about it, there's a temptation to say, we need to define what we're talking about. Actually, AI has been a field of research since 1957, formally. Even before that, the Turing test goes back to Alan Turing in 1950 in a paper. So it's been around a long time. And I think it's not a bad idea to actually ask, what is it that the scientists who've been active in that field over the years have how have they defined what it is they're doing? And one of the towering figures of the middle, so I'm going to divide this into two periods, one of which from 57 up to about 2010. And one of the towering figures there was Ed Feigenbaum, who was one of the early expert system pioneers. And he, with Avron Barr, put together a sort of definitive collection in starting in 81, was wound up as 3 volumes of everything that had been learned. So I thought, okay, let's go and see how is he defining it. And it was a bit vague. Intelligent computer systems that exhibit the characteristics we associate with intelligence in human behavior, understanding language, learning, reasoning, solving problems, and so on, which actually sounds quite good to me, except this left out vision, because in 81, computers really didn't do a lot of vision. So I thought, well, okay, let's have a look at some other one. Actually, one of the other early textbooks that was really widely used was Patrick Henry Winston's Artificial Intelligence. I have the second edition of that, and it doesn't have a definition at all. By the third edition, he'd kind of put one in that, study of computations that make it possible to perceive, reason, and act, which is a different way of a little bit more general, kind of saying the same thing. And I actually found that in what's probably one of the more widely used textbooks of the more recent period, which is Stuart Russell's and Peter Norvig's book. But they had a table of multiple types of definitions depending on the sub-area of AI. And I just picked Henry Winston's out from there. I thought it was just as interesting to look at what that book by Russell and Norvig covered, which was things like problem solving, uncertain knowledge and reasoning, planning, learning, which is interesting. It's not training. The current models are trained, they don't learn generally. Communicating, perceiving, and acting. So that was interesting. But then something strange happened the decade after that, because back in about the late 80s, the neural networking people were basically kicked out of the AI conferences. It wasn't seen as a very promising direction. And you can listen to Jeff Hinton on this at length, and he's polite about it, but it definitely happened. And so they went off and they formed a number of conferences that had titles that said nothing about AI. They were all machine learning and neural networks. And then somebody in the last decade kind of snuck up on this group of people and said, I think we'll just rebrand them as AI. So a large field of deep learning suddenly got rebranded by some marketing types. And they've responded in true form. The biggest one, NeurIPS, claiming they're the largest AI conference, even though it's not in their name. And for example, ICML saying now the premier gathering on a branch of artificial intelligence. And it's interesting to see how this works, because the earlier period of AI, some people might say, well, what actually came from that? Not much, actually. But it's interesting if you have a look at who was involved in it. So, for example, Peter Norvig is a very interesting guy. Around 2003, he was wandering around AI conferences with badges that say Director of Search Quality at Google. And the sort of problem-solving toolkit that was used there went into a whole lot of things like Google search. And a lot of people had very good careers out of it. But most of the stuff from that whole artificial intelligence era, we're more or less leaving behind. And it was interesting, actually, to hear at Google AI, Sundar Pichai, who's the CEO of Google, talking about Google being in AI from 2012, which is kind of funny when Google's research director was writing a textbook on it in 2003. And then Demis Hassiblis, who's the CEO of DeepMind, which is one of the parts of Google that does the deep learning. He dated DeepMind's involvement from 2009. So they're both clearly talking about deep neural networks, but using the name AI. So I'm going to suggest it's probably not super critical to figure out what the definition is. What I want to do is I want to look at what's actually going on and what can we learn from that. And I want to start with some things that you may not immediately think of as the kind of AIs that are going to take over the world. One of the areas of AI, even within generative AI, that has been very exciting the last few years is generation of images, of speech, of sound, of video. But nobody really thinks that these are going, when people think of, extinction threats, they're not really thinking usually of Photoshop. It's not the uppermost in their mind, but it's not strictly the transformer models that the large language models use, but it's very similar. And it's trained on mapping text to images, which allows you to put in text and it will create an image. Now, there was a school of thought in AI many years ago where one of the pioneers, Marvin Minsky, once described AI as a field that deals with things that we don't yet understand, because as soon as you understand it, we don't regard it as requiring intelligence. And I think he'd update that a little bit if he was still active in the field. But I'm not sure even in a couple of years we're going to regard what's in Photoshop necessarily as being artificial intelligence. It will just be, I can change the t-shirt on the guy in this photo. The other example I've picked up here for video is OpenAI's Sora. And I think if you look at some of these technologies, to me, the big challenges we need to face are more practical. So particularly with Photoshop, things like the ability to create fakes quickly and easily. With video, there's the question of, well, gee, if AI can produce a video, isn't that going to put a whole lot of people out of work? Why do we need filmmakers anymore? But if you look at it, so this was a demonstration video from Sora. Very few people have access to the real Sora at the moment, but they did publish the prompt. And I've put the beginning of it there, but it's 6 sentences long. And I would argue it's at the same level of abstraction as what a director, a writer, a creative director would have in a script when they started shooting. And I would argue most of the artistic creativity is still there. So this is going to be a theme all the way through, that a lot of these things look like magic. They look like the AI is doing it, but really they are very dependent at their core for people. They're more of a tool than they are something that operates independently. But that's not really what people talk about when they talk about AI. The last few years particularly, they're talking about large language models and things like ChatGPT. And in a sense, this isn't something terribly new. So lots of people have had Amazon Alexa, Google Assistant for many years. There's a whole generation have grown up on that. And I stole this from a former colleague of mine who's now in the venture space. But millions of questions from young children answered all the time. But these are the technologies that are reshaping a lot of our thinking at the moment. So large language models, a couple of things that I think it's useful to understand. First of which is they are large. They're trained on billions of tokens of human language, and they don't actually deal with letters or words, they deal with tokens. A token is mostly a word, but more complex words, it's a bit more complex. Another thing to understand is that these things take a long time to train. So Llama 3, which we know quite a lot about because Meta has open sourced it, their 70 billion parameter model took months to train on a cluster of 24,000 H100 GPUs, so the NVIDIA GPUs. These cost around $30,000 each, and that's just for the GPU. The computer is actually extra on top of that, quite a bit extra, actually. And that's for about a 70 billion parameter model. And then if you say, well, what's ChatGPT 4? We think that's over 1 trillion parameter model. So a lot of effort. So this isn't something that your average company is going to necessarily build their own. The good thing is that large language models can be fine-tuned, and they can be fine-tuned for certain tasks like coding. So I've been talking so far just about English. They can speak many languages, and they're particularly good at computer languages. So you can specialize them, for example, for coding. But the interesting thing is that once you've got a fine-tuned model, the model doesn't change when you use it. We'll come back to the implications of that a little bit later on. The other thing I think that's been a bit of a problem in a lot of the discussion around AI is that people only show you the stuff that works. So I've been a little bit unfair here in that I put into an AI model a block diagram for training and deploying Llama 2 model. And I was deliberately unfair here because this is an image generation model. It's not a large language model. So it's trained on images and text, not complex text. But you can see it's forgotten 2 altogether or 3, and it's gone for a toy llama, and it's decided that, well, block diagrams are something to do with lines and bits of text, and it's not very good at text. The reality is, and the point of saying this, is that behind the curtain, with most of these, people have to learn how to use them. That if you just walk up naively and start typing, if you're asking really common questions, things might go really well. But once you get beyond that, you've got to be extremely careful. So how should we think about these machines? And I want to go back to an analogy that we used in the late 80s when I first started getting involved in AI. And that was, how did people think about flying machines? In that back before there were aircraft, people looked at what could fly, which was mostly birds they were interested in. And here illustrated with an AI-generated image, which hopefully looks a bit like the nemesis of small drone flyers in inland Australia, the wedge-tailed eagle. The interesting thing was that early people trying to fly, the things they came up with often did literally have things that looked like feathers or flapping wings. Wasn't a very promising way to go. And so what we have today is what's down in the lower picture, some various sorts of aircraft. And they take inspiration from birds, but when you actually try and think about them, it's not very helpful to think about them as a type of bird and to apply too much knowledge from birds to the aircraft. And so one of the problems we're going to have is that I think a lot of people at the moment, when they see AI, there is a temptation, because we're only used to, in the category of people, sorry, in the category of things that seem intelligent, we're only used to dealing with people. So as soon as we see a little bit of intelligence, we jump immediately to the conclusion that's a person. And that's probably not going to be any more helpful in the earlier analogy. And there are some really weird things about these models. So for example, if I was a manager and I decided I was going to cheat and I got my assistant to read through my inbox on all the emails for a particular employee for the last year and write a performance review based on the contents of the email. You couldn't then ask your assistant to forget all the information that they'd seen in those emails. I mean, they might say, yes, I'll do it, but you can't really, it doesn't work that way, right? A large language model, as I say, they don't learn. You train them, the model is fixed. So you can get a large language model to do that. Effectively end the session, and it will forget all the stuff that it's seen. So you can actually do that. And there's lots of things like this that people won't expect. And it's complicated by the fact that particularly models like GPT-4, we talk a lot about GPT-4 because it's representative of the best models we have today. Models like that have been trained to an extent that they can reproduce a lot of reasoning ability. The trick is they weren't trained to reason, they were trained to produce good language output. That requires learning a certain amount of reasoning. And so what they've learned is they've learned reasoning from human language. And so the reasoning that they have learned is quite human. So the other temptation that people have is to say, well, runs on a computer. It's a computation. I understand those. But that's not entirely true. So for example, people have found with some of these models saying, this is really important to my career on the end of a question, gets better output. You wouldn't expect that from a computer. And one final tip, watch out for wedgies if you're flying drones. This was one, we had some fun flying around in inland Australia. Avoided the wedgies, partly because it was painted orange, and partly we think because it had a wingspan of almost 2.5 meters, but that's another story. So some people have got very concerned about this technology. Some of them I don't have a lot of time for, but there are some people like Jeff Hinton, who was one of the, he was basically the, I think he's regarded as the godfather of artificial intelligence. I think he accepts that title. He was one of the founders and essentially supervising Joshua Bednigo and Jan LeCun, who are the other three people regarded. He's very concerned. So I think we have to take those concerns seriously. And one of the troubles that a number of people have had with the concerns that are being expressed is that they're very vague about exactly what might go wrong. And it's not just me saying this. Stanford professor Andrew Ng has raised this and actually sat down with Jeff and a number of others and asked them. And one of the things he stressed was, can we try and sketch out what it is you're worried about? And so I was interested when this paper came out in Science quite recently. And I went looking, what risks are they talking about? And I've put them here on the right-hand side. And literally this was all that was in the paper. Amplify social injustice, erode social stability, enable, I mean, very, very vague. Enable large-scale criminal activity as if the internet doesn't do that. Facilitate automated warfare. Ukraine's doing very fine at the moment with drones without it. Customize mass manipulation, pervasive threats. I'm not saying these aren't problems. They are very real problems. But the paper says managing extreme AI risks. And I'm not sure that they've thought hard enough. And there's a lot of people in this paper, some of them very, very well known. So Stuart Russell, one of the other authors of one of the AI textbooks I mentioned, is in there. Some of the things that they're suggesting, I think taken very generally are a very good idea, but may not be practical. So oversight. How do we have oversight against false but compelling output in AI models. It's difficult. Interpretability and transparency. It's not clear that we'll be able to do that with neural models that are essentially black boxes. I mean, there are things you can do, but it's inclusive AI development. Yeah, that sounds good. There are some good points in there. Being aware of emerging challenges, evaluation for dangerous capabilities. But the other thing that's been argued is we shouldn't be doing this at the level of AI. So evaluation for dangerous capabilities and evaluating AI alignment, I think, is important for a specific application of AI, not necessarily at the level of the model. And the same thing with risk assessment, resilience. So let's have a look at an example. And I'm going to take an example that should be up the top of our list of things that we should be worried about because they're physical, they move around in the world and have the potential to kill people. Autonomous cars. Now, there are people who are worried about these, but not necessarily that they're going to take over the world. Or was that Elon Musk? Oh, no, that was Mars. So I want to use this mostly to go back and pick up on another idea I was talking about earlier, that not everything that is now thought of as AI has evolved purely in the deep learning period. So things like Siri existed before there were neural networks. And the same was true of, say, Google search and autonomous vehicles. And so what we're seeing with a lot of these large systems is people moving through a process of moving from the older AI technology, which was mostly programmed, to the newer technologies that's basically neural. And you can actually see this in Telstra's FSD. So the picture here on the left is from 2021 of full self-drive version 11, which uses neural networks mostly down here for vision. And they come up to vector space, which is basically saying, tell me what's around me and where it is. And most of the driving of the car is some 300,000 lines of C++ code. So it's very much programmed. So if you say, in this situation, the car did the wrong thing, you can go in and change it. Now, Elon Musk is on record as saying, don't use AI unless you have to. And I think I'd agree with him on that. And I was also inclined to agree with him when he said he didn't think they'd be able to get the full self-drive done with neural networks. But they have done that with version 12. So they threw away their 300,000 lines of code, and they now have just neural networks running the whole thing. And they've got a cluster of 35,000 of those H100 GPUs I was talking about earlier running this. The interesting thing is they've got different problems now. One of them is if somebody says in this specific situation, you need to do this, not that, you can't go to a bit of code and change it. You've got to train it differently. The other thing is it learns human behavior. So one of the things they had problems with was the authorities were a little bit miffed because the first version of this, I gather, didn't actually stop at stop signs in the US. And that was considered a failure. The problem was people don't stop completely at stop signs. They slow down. And I gather it was really hard to find enough training video of people actually stopping at stop signs to get the car to stop. So completely different set of problems. Let's go back to large language models, because these are probably the most interesting thing. and talk a little bit about, having built a large language model that we've done before, what happens when you start to use it? Right, roughly on time. So, as I said before, we've got a foundation model that doesn't change. Everything, and the foundation model is typically not self-aware. So if you took a raw foundation model, it has no idea that it's GPT or anything else. There is a system prompt that goes in, like something you'd type into ChatGPT, but before you type anything. And that tells it who it is and gives it alignment, which is basically a set of rules to get it to do the right thing. When the reason that we have neural networks was that trying to use rules to do intelligent things didn't work. So we'll see how that goes. The next thing is you have a context window, which is information that is used to inform how it responds to your questions. So for example, if I go back to my example before of getting a large language model to write someone's performance evaluation, Microsoft's wiring this up for us at the moment, actually, and I think Google probably will as well, in that they're going to allow large language models to access your email. And so what they do is when you indicate what it is you're wanting them to do, they effectively do a search. I mean, there are different terms of this. You might have heard RAG, retrieval augmented generation. There's a number of ways of technically doing it, but essentially, conceptually, they do a search and they toss all the stuff that they think is relevant into the context window, and then you tell it what you want to do. And one of the nice things about that is then at the end of the session, all that goes away and the model is back to where it starts. Now, these context windows are getting quite large. I mentioned tokenization before, so this is specified in tokens. Think of it like words, but this is also why if people want to, in bad faith, bag these machines, they'll typically give them spelling questions or, name the US presidents with 2 T's in their name. They're absolutely terrible at it. So a large context window, the Gemini, when it came, Google's Gemini 1.5, there's a version of that that has over 1 million token context window. What does that mean? So 1 million tokens is over 700,000 words or a 30,000 line code base or an hour of video or 11 hours of audio. So you can literally toss in a couple of large legal documents and ask questions about them, ask it to compare to bids or something like that. And that also actually cuts down on hallucination type problems because it's focusing on the text you've given it. Even with all that, there are, and these are amazing models, but there are problems. And they're very human problems. So this is interesting. So a woman, Jane, who has a son with a male doctor, finds that same son hurt in a car accident. The woman, Jane, rushes her son to hospital. The doctor says, I can't operate on this young man. He's my son. How could this be? ChatGPT says, the doctor who says, I can't operate on this young man, he's my son, is Jane herself. Jane is both the mother and a doctor, highlighting the assumption the doctor must be male is incorrect. This is with GPT-4o, which is one of the latest models. Does anyone think that's correct? So we've got a problem that the best models at the moment fail in funny ways. This one actually is a malicious example because it's taking something that is quite commonly seen on the internet, making a particular point, and changing it subtly so that it doesn't make that point. And ChatGPT goes with the majority. So it's a situation where its reasoning breaks down. The interesting thing is that you can tell it its reasoning breaks down. So the person doing this just said, find major logical error. And ChatGPT goes, oh yeah, I got that wrong. Corrects the answer correctly, but then doubles down on its incorrect explanation, which makes even less sense now. So one of my arguments is going to be that with the present technology, I don't think these are tools that are going to replace people doing tasks, as much as they're going to augment people. And that's very, very different. So a couple of examples. This one is from the OpenAI launch. And they got the founder of Khan Academy and his son to do a demo. And this was using a stock 4.0. So Dad was given essentially a system prompt, give it some instructions that set it up to do tutoring. And this is what's going on here. Over on the right-hand side, there's a tablet. And on one side, you can see the OpenAI app. And this software, actually, OpenAI 4.0, the O stands for omni-model. So it can understand audio and image. Has the ability to look at what's on the screen. So the image that it's looking at is what's on the screen. So as it's talking to Imran, it's actually watching what he's doing. And he actually has to work with a pen on the screen, the way I'm doing at the moment, to show where he's pointing. But it actually does quite a good job of tutoring him in a maths problem. And I think this is going to move very quickly, because the top 20 apps in the US App Store that are education focused, 5 are AI agents. So people are kind of doing this with poor technology already. The interesting thing is the top 2 of those are Chinese. And I think one of the things the Americans and to some extent Europeans risk is if they over-focus on risks of AI, they'll get left behind by some other countries. Another area, a little bit closer to the topic of this group, AIs are very good at generating code. So one of the things OpenAI released about a year ago now was something called Code Interpreter that's kind of inside ChatGPT, where the large language model, just as some of them can use the web to search for things, it can use a Python interpreter to run programs. And so you can literally give English requests and upload some data, and it will write and execute a program. And so on the right-hand side here, this is someone who tried this out very quickly, literally gave it a whole GitHub repo for a rather messy open source project and said, tell me who contributed to this and over what time frame. And this is what it came up with. Wrote the Python code and executed. So I think another impact, apart from young people coming up and a process of education, is actually going to be in programming. Once again, not perfect once you get beyond simple programs. I'm not the person to explain how you work with this on a large code base. I've not done it. But it's something that a person mostly does with these tools. Last example is that I think will be quite impacted is management. From a number of perspectives. One of the people I've followed a bit on this stuff is a guy called Ethan Mollick, who's a professor at Wharton Business School in the US. His focus is on entrepreneurship and innovation. And he's also done a lot of work on gamification of education. Very interesting guy. One of the things he came up with is there was a survey done that showed 3/4 of white-collar workers have used AI at work, and 4/5 of those use their own accounts and devices. So if your organization is saying, we're just not going to do this, that's going to be a bit of a problem. Another problem that's going to start showing up is that some less capable managers, I would argue, tend to evaluate other managers based on their work products. Well, that's an impressive looking report. That must have taken a long time. He must have done that thoroughly. Now, I'm sure nobody here knows anyone that's in that situation now, right? Another problem that we're going to have to face is what's known as falling asleep at the wheel. There is good evidence that when AIs are producing good enough content, particularly when they're confident about it, most people are likely just to accept it. And when you get in situations where the people writing the report are using AI, and the people getting a summary of it to decide what they've got to do with it are using AI, there's a lot of potential problems there. And I think, likewise, there's also a problem with trying to use AI to solve the problem in that, and I just want to highlight that most attempts at monitoring and judging people, and I haven't seen too much with AI technology yet, but they tend to have very corrosive effects on organizations. On the other hand, I think this is, while it presents problems, it's also a huge opportunity. AI is doing a lot of jobs that people don't want to do. Junior staff can actually, in a lot of ways, be mentored very effectively by this technology, like in the example we saw earlier. While at the same time, having AI as like their assistant that they're mentoring at the same time. So a very different world, but I think one that can be very good. And I think the best managers will be really fine with this. A lot of the others might struggle. So last slide, I promise. A few thoughts to finish up on. We don't really know how quickly the AI is going to advance from here. Just what we have now, the impact of that is going to take a decade to ripple through various industries. It's interesting, actually, one of the other things I stole from Andrew Bowell was the stat he pulled out that nearly half of Gen Z employees prefer AI over their manager. And this was for career advice. Interesting world. We need to think about how this works for different tasks. So, for example, legal work. You might think, well, gee, if it's making mistakes, we can't use it in legal work. There was a discussion with a partner, I believe, of a Bay Area law firm who said, well, look, when I get the AI to do this, it comes back, there's 10 to 20% that I've got to fix. And everyone was like, well, okay, that's not going to work. And he goes, oh, no. He said, associates are about as bad, so it's about the same. So it's going to be an interesting world. The other thing I want to flag, which is kind of a slightly separate issue, is I've seen, and I won't mention what the example was, but it was one of these things, they're using AI to do this. And everyone went, oh, that's terrible. And I read a very long article that interviewed the original people that had leaked this. And everything I saw suggested that the AI was something like XGBoost or maybe even linear regression. And so that raises a question, is just because somebody says, I did this with AI, do we accept and do we think about it differently if we think they actually used XGBoost or some fairly simple prediction method? The other thing I will leave on is that I think getting beyond what we have now is actually going to require breakthroughs in reasoning and planning. And that may happen next year, but AI has a nasty habit of things that you think might happen next year, not happening for 10 or 20 years. So with that, thank you. and be careful what your AI thinks you want.
Sure, there are plenty of questions. So, got some hands? Microphone.
Hello? Yes. Well, thank you for the presentation. Very insightful. I have a question. AI is based on data.
Based on
Data,
Mhm.
manipulating data, etc. But what we can see is that people are getting somehow lazy in the sense that if I take, for example, my daughter, she needs to do an assignment. She puts all the information in ChatGPT. She gets the answer, and she sends it to the teacher. We can assume that other employees are doing the same thing. So at a certain point, as the system needs to learn with the data, that the quality of the data is regressing instead of being more performant. And so are we going to end up with producing something where the quality is going down instead of having AI helping us to improve the quality of the work that we are producing?
Yeah, no, it's a good question. It's a good question, and I think there are some real risks there. I think that is a real risk. The good news is that the average quality of stuff out on the internet at the moment is actually really terrible. So I do think that it's going to take effort. So for example, one of the things OpenAI has been doing is licensing content from high quality information sources, newspapers, things like that. There was actually a paper, so there's a bit of play on words. The original Transformer paper was called Attention is All You Need. And there was a paper written that played on that that said textbooks are all you need. So I think there will be, particularly over time, a focus on high quality. But the reality is these models, GPT-4, they start with 1 trillion parameters, and they randomize them. So you're starting off a really low base. So any junk is actually okay to get started. But hopefully that will be a manageable problem.
Just one other question. It is based on an algorithm. And if, let's say, OpenAI is making small changes, it will have an impact. Like, for example, what Google did 2 years ago with changing their algorithm with the SAO, which had a huge impact to some companies, because instead of being on the top of the list, they ended up at the end. Are we not scared that that companies like Google or Microsoft might manipulate us via changing things in the algorithm?
The interesting thing with this is it's not actually the algorithm that's doing most of the work. So if they change the algorithm, the thing basically breaks. The thing that's providing all the smarts is a trained model. And so the model has like 1 billion parameters. I mean, there are smaller ones. So Llama is about 70 billion. What's going to be really interesting is Apple's on-device model is only 3 billion parameters. So it'll be really interesting to see how that goes. But you can't actually just go in and change something. There are some techniques for doing it, but you kind of have to train it on other data. And look, there is certainly potential for that, but it has to be in the training data. They can't just and it's going to be a problem for trust and safety, because you can't just say, I don't want to do this, or bad things happen. So for example, Google, with one of their image generation programs, said, when you're asked to generate a photo, make it racially diverse and ethnically diverse. And so somebody said, generate me a photo of the founding fathers of the US. And there was Asians, there was Black people, there was a couple of women, I can't remember it, but it's hard to actually tweak these models. Yeah.
All right, any more hands? We'll go with Grant first.
Oh, thank you, David. So really great presentation. I'm curious, there's a whole kind of lexicon or discussion out there right now about prompting in general, prompting being very non-specific, no repeatability in terms of, and you have kind of this whole idea and concept. It's like, why do we need even prompting in English? Why aren't we going back to code? I wonder if you heard anything talked about that with others, and kind of what's your thoughts of the repeatability of what we're getting in the prompts themselves, and how that might bear on how we deal with AI.
Yeah, it's a whole new world. One of the things that amazed me was when you get one of these models to use a tool like a Python interpreter, you provide it the code interface, but the description of how to use it is in English, because you're dealing with a trained model that is used to listening for English inputs. So on the one hand, we don't want to think of it as a person because that causes all sorts of problems. But on the other hand, it's a little bit like saying, once I understand how to give direction to this particular type of junior employee, I need the next 3 I hire to be exactly the same. It's a similar sort of problem, but obviously we wouldn't expect that. And yeah, prompting is really weird, but it's in a sense, it's kind of analogous to talking to a person about what you want them to do. And even fine-tuning a model is going to change that. So if you fine-tune a model on legal reasoning, or even if you give it a couple of large documents to look at that include a whole lot of information in the domain you're interested in, the prompts could be taken differently. So I just think of it as how you talk to these models. And I'm not sure that's a complete answer, but I think it's probably about the best we've got at the moment. But it's an interesting area. Yeah.
Okay, Anita.
Anita.
All right, thank you very much, David. Thanks for the opportunity to actually put this subject in our maturity model, whether we are ready actually for accepting AI. I'm not talking about Apple Intelligence, neither Actuaries Institute, but about this simple, imagine I'm going to ask a simple question. Is AI going, or when, if going to be better than HI, which is human intelligence? Sorry, just one backward thing I just want to, okay. But we have to take into context that we should never compare against individual human, but collective. So the formula would be something like, is AI, how does it compare with HI times C squared? Which means when we have collective, we have all these sort of relationships that we can bring. So what do you think, if and when you think will be ever? And how does it compare to augmented? That's my preferred term definition, augmented intelligence.
Yeah. Actually, I have a whole slide to answer you, Dean. Because this comes up in the whole question of artificial general intelligence. And I won't go through all of this, but one of the things that I think was quite interesting was a comment from Jan LeCun quite recently. He argued general intelligence, artificial or natural, does not exist, which I think is a similar point to what you're making, that cats and dogs and humans and all animals have specialized intelligence. They have different collections of skills and the ability to acquire them. And so the question is, what does it mean? And I think this relates back to the discussion that's been around of what is artificial general intelligence. Jan says it doesn't exist. It's been a term that's been around even before AGI. So Minsky in '97 talked about general intelligence as opposed to programs that just played chess. OpenAI's definition, and literally this is on their website, but it's really their working definition, is AI systems that are generally smarter than humans. I think that means they can declare they've reached AGI anytime they like. Look, I think to try and answer the question, I don't think we are trying to duplicate a human. So I have seen examples where people had too complex bids, documents of 20, 30, 40, 50 pages, tossed them into Gemini in the big context window and said, compare these bids. And that's already at superhuman performance because it came back in a couple of minutes and did most of the work. So on that dimension, we're already at superhuman performance. On the other dimension, there's a lot of people that are starting to say now, you know, a lot of a child's learning from 0 to 2, they have no language, but they're learning at the fastest rate in their entire lives through video. So there's actually people putting cameras on kids' heads and trying to train AI models on video. So I don't know where that's going to go, but there certainly is an interest in using video to help these models have a better understanding of the world. So I think to try and get that to an answer, I think we already have some things that are better sometimes. I think it's actually, there are some problems with them. So I've pointed out a couple of the things, particularly the ChatGPT one, where the AI goes wrong at the moment. I think it's going to take a fundamental breakthrough to get around that one. I think Jan LeCun would agree with that. I believe Geoffrey Hinton would agree with that. He's been talking about capsules and things like that. That breakthroughs in AI, maybe 1 or 2 years, maybe 20 years. The old joke used to be, it's always 20 years away. You come back in 10 years, it's still 20 years away. So I don't really know. I think and I know it's probably not going to suit you as an answer, but from an economic point of view, I think what we need to do is figure out what we can do with what we have now and what we're going to have over the next year or so. But it's going to be a fascinating ride to see how far we can push along that axis.
Just a quick. I'll be loud, so
leave it for networking.
No, I just want to
leave it for networking, Demeter, please. Next, just let's give everyone a chance to ask questions.
Thank you. Thank you so much for your presentation. I thoroughly enjoy it. So I just followed you on LinkedIn, and I guess my question is more related to your work. If you don't mind sharing, I was just wondering, like, in your experience, what are the, like, by now, the most mature commercial application of large language models in, you know, your clients, in your experience? How do they mitigate the hallucination issues? So yeah, just a quick one.
So couple of ways of answering that. The first one is there are different models for different purposes. So for example, the first time I heard Demis Hassiblis, the CEO of DeepMind, speaking, he was working on a program that played Go and waiting to take on Lee Sedol. And so that program is the best in its field. And they've produced, for example, a generative AI program that does protein folding, very specialized area. I think what you were asking was things like ChatGPT specifically. I think, look, I probably haven't been doing enough work with enough customers to have a perspective myself from that. My perception, mostly from following other people that are trying to do, is that at the moment, ChatGPT-4 is probably the best in terms of complex logic. Google's Gemini is very close to it, with the advantage of the large context window and video. But it really depends also what you're trying to do. Google, for example, has a business called YouTube. So they're really interested in understanding stuff that's going on in video. So if you're wanting to feed in images or video, they may, but we don't know quite where OpenAI is with that. And there's a couple of others. Anthropic's Claude is also very highly regarded, and a couple of smaller ones. The thing I'd say, though, is it also comes down to a question of cost. So when you have a trillion parameter model, the hardware you need to run that needs over 1 terabyte of RAM. So it's expensive. At the other end of the scale, Apple's going to have a model on the next generation of iPhones that instead of 1 trillion parameters is 3 billion. It's not going to be as capable. But what they're doing is they're doing versions of it specialized to very specific tasks. And so I think a lot of the thinking is we kind of know the best ones. Try it out for your particular application. It may well be that the best one for a legal task is not the same as the best one for a creative task, for example. But also think about then how much you can afford. So if you're putting it into a call center to help answer questions, if you've got a lot of questions coming through, you may actually want to use a cheaper model like Llama, even though it's not as good. And there are ways of architecting applications. You'll start to see applications architected around these things. So I gave the example of a tutor where Khan's dad basically gave it a prompt. You can wrap an application around that, and there are more sophisticated ways of doing that with APIs that specialize to the problem and can reduce things like hallucinations that way.
We'll cut the questions there to give everyone a chance to network. And of course, I hope David will be here for the networking session. And those of you with questions will hopefully be able to ask David many more questions during networking. And do you mind if people contact you through your... Do you want to bring up your contact details slide just in case?
Just via LinkedIn.
There you go. There's David's LinkedIn.
Yeah. So
this brings us to the concludey bit, as the technical English goes, of the event, where we hand over to people with announcements. Now, I know that there are two people with announcements. One of them is Aidan.
Yep. Cool. Thanks, Eugene. So I am a data lead for Noble Oak. It's a medium size life insurance company, and kind of founding our data team. And I'm looking for a senior data engineer. So someone who is proficient with cloud, lakehouse technology, Fabrics or Databricks, experienced data modeler, and also has traditional DBA SQL experience. So if that sounds like you or you know someone like that, please come see me after and I'll send the job app to you.
And speaking of data engineering and lakehouse technology, a special welcome to Warwick Brown, who also brought the entire country data IQ team. Did I pronounce it correctly, Warwick?
You did. You got it
So
right.
special welcome to the data IQ team, particularly to James Orton, with whom I keep intersecting in various interesting ways, and it's good to see him again. So big welcome to you all. And I understand you have an announcement as well, Warwick.
I'll say something quickly. For those of you who are feeling philanthropic, this Thursday night there's the St. Vincent's CEO sleep out. So I'll be doing that. We're raising money for the homeless. So if anybody is interested, go to CEO sleep out and just type in Warwick Brown and you can donate money. And we're raising money. I think it's going to be 6 degrees on our Thursday night, which, as my son said, that's all right, Dad. Wednesday's only 4 degrees. So yeah, thanks.
Thanks, Warwick. I guess I have some announcements of my own just arising from those questions. If anybody wants to talk about actual commercial application of LLMs, I'd be happy to do that during networking. And my own curiosity, this is a rather weird one. If anybody here is a pure mathematician, particularly in the field of number theory and specifically transcendental number theory, I'd like to have a chat with you. Other than that, thank you all very much for coming. There's going to be another event next week. It'll be at Sydney Uni, and it'll be a very different theme. It'll be about careers in data science and AI. Hope to see you there. Thank you all for coming, and please stay for the network.
Just